Here's video help for problem 10.7, part A. We've got a pi over 2 pulse, and we've got our slice select gradients and rephasing. So we're in some slice, and right at this point we've got zero phase. And now let's look and see what happens when the phase gets changed by the y and the x gradients. Now remember, what we've got here is the phase is equal to minus gamma g, the gradients times the positions times time. We take, for example, in the y direction, we take and look at the coefficient of y. For a given y, that coefficient is changing. We're watching phase change in different directions, and actually we can talk about it in terms of a k value. The ky is gamma bar g phase in code times the time. Kx is, involves the read gradient, and I have the gamma bars because I factored out 2 pi. Now look at what happens. Ky is changing as time goes on, and it also changes if I change the gradient. I won't change the read gradient, but it'll change with time. And what we want to do is see how are these k values change, and that's going through k-space in this two-dimensional k-space. So look at this. For this, remember what a gradient table means. It means we go through first at this biggest value with the arrow going down. Then the next time through, it's the next value down and steps on down all the way to a negative gradient value, as negative as it was positive. Whereas the read gradient will just always be exactly the same in strength, but both of these grow with time. So what's going to happen the first time through? Sort of number one. I'm at the maximum gradient value, and I grow from 0 to the value that I get at this time. And here I also started 0 phase, and I grow with time to the same point in time. And so look at what happens. Both of these are changing at exactly the same time. So ky is changing, kx is changing at the same time, but the first time through, ky will go to the very biggest value. And kx is going to the biggest value every time. So it's going all the way up to here the first time through. Then when we go through again, it'll go just a little bit lower slope, because I've got a little bit smaller gradient here, but I've still got the same gradient strength in the read direction. And so it would go, 1, 2, 3, all the way down, and the last time through, the gradient's negative here. So I go to the negative maximum at the very bottom there. This is as negative as this is positive. So that's what happens to me when going through this thing every time. Now what happens after that, any one of these times? Well, first of all, I've got a pi pulse. A pi pulse, as we know, means phi goes to minus phi. We imagine, the usual thing where I'm, say, taking the pi pulse around the y-axis. But phi, in general, is minus 2 pi k dot r. Phi go to minus phi means that k goes to minus k because, r isn't changing. And so I've got ky go to minus ky, kx go to minus kx, and therefore this goes all the way down to there. And this one goes to a little bit above it. And this third one goes a little above that. And then finally this guy here goes all the way up to there. So as a result, we now have 1, 2, 3 up to the maximum, maximum number of steps all the way up to ky. So I start at negative ky going up to positive ky. As a result of the pi pulse, I'm along this vertical line somewhere in this region here now, after everything is done except for reading the data. Reading the data, I'm just changing I'm just changing kx. You know, due to time, gr is fixed. Time marches then on. I keep going through steps. I change the kx. I'm going to take every one of these kx's and go straight across. And I go straight across the first one, 2, 3, 4, dot, 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 all the way up to the top. You see, because this is twice as big as this left us negative as possible. This, therefore, can take us from the negative most value through 0 to the positive value, because this is twice as big as that. And that's where we would get, oh, I drew my lines up here. I had drawn this intending to show you these lines here, starting here, going straight across here, 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 and all the way up to the top. And I've covered k-space. For part B, it's now pretty easy to see what will happen. To start, in part B, okay, I selected my slice. Now, the only thing that happens in this time interval, remember this is always time, this time interval, I just simply go from 0 phase to maximum phase in x. So that's kx going from 0 all the way out to a maximum value. Every time it'll be like this. Then a pi pulse. It's only this thing, and then the pi pulse then just takes kx go to minus kx, ky is 0. So it will go over to here, and now I'm there. And this gradient table now, and again, I'm just going to use this picture. I don't need this second picture. I was going to put these 2 steps in 2 different pictures, but I can do it all in one. What's going to happen here? I'm going to go, the time grows, over this interval, but also I'm at the maximum value of the gradient in the y direction. So what I'm going to do is, see, I'm here. I'm just going to go all the way to the top. So this will be where I'll be up here the first time through. Then a little bit less, and a little bit less, and I'll go all the way down to the most negative value as I go through this table, as I repeat this sequence. This is the most negative value here. So when I have step 1, 2, 3, I've got 1, 2, 3, all the way down to, the final number of steps. And there's where I am at this point, right between this gradient, this table, and I start to take data. Again, only x is changing. Only kx, therefore, only the gradient x is changing, so therefore only kx is changing, and it grows with time. And again, this is twice as big as this, so I can start here and go all the way to the other side. And then the next time through, all the way horizontally, every time, going all the way through, finally getting to the end, I have covered k-space.